scenario prepared by authorizing him. So the networking requirements, we have given an IP address and mask of 172.20.0/24 network, and we need to design an IP addressing scheme that satisfies the following requirements. So you have subnet A, which is going to have 2 hosts. You have subnet B, 6, C, 47, and D, 125 hosts. So the topology will look something like this. So you have subnet A, subnet B, C, and D, like so. So in this case, we're going to use what we call classless subnetting. Or in other words, it's called VLSM, variable length subnetting. And so what do we do now? What is the first step of VLSM? So you write down the IP address in binary like so. So you have 172.20.0, and because it's a /24 IP address, the last octet will be like so. So that's your /24 network, and your host bits, you have 8 of those. So with classless subnetting, the next thing is you've gotten your IP address in binary. Now we need to determine the largest network. So here, subnet D with its 125 hosts is the largest network subnet in here. So to cater for those 125 hosts, how many bits do we need to represent them? Yes, we need 7 bits, just like so. Yeah. So these are the 7 bits to be used for the host, and we have 1 bit left over that could be used for subnetting. So how many subnets can we have with 1 bit? We can have 2 subnets, like so. So that's your first one, the all 0 subnet, and then your second subnet. So we're going to allocate the first subnet to subnet D. So in decimal, your first subnet is like so. So 172.20.0.0/25. That's your first subnet. Now we're going to determine the subnet mask. Yeah. So remember what a subnet mask is? Yes. Your subnet mask determines the number of bits used to represent the network you subnetted network address. So your /25 subnet address, you have a /25, therefore your subnet mask is going to look like so. Yeah. So in decimal, it'll be 255.255.255.128. That's your subnet mask. Now we're going to determine the first host address. Remember how to do this? Yes, the first host address is equal to subnet plus 1. Yeah. So it'll look something like that. That's the host address. first host address. Now we're going to determine the last host address. Remember? Yes, the last host address is equal to subnet plus 2 to the power of 7 minus 2. Yeah, because you have 7 bits that you're using to represent your hosts, 7 bits. So with 7 bits, that's why you have 2 to the power of 7 bits. Out of those 2 to the power of 7 IP addresses, 2 of those are not usable. Yeah, so that is equal to 172.20.0.126. Yeah, that's the last host address. Okay. So we're going to determine the broadcast address. So far you've done the network address, subnetwork address, and then you've done the the first and last host addresses. And then we're going to use, we've determined our subnet mask. And now we're going to go and have a look at your broadcast address. Yeah. So broadcast address is equal to subnet plus all host bits equal to 1. So it'll look something like this in binary. Yeah. And then in decimal, it'll be 172.20.0.127. So now that we've gotten subnet D, the largest subnet, sorted, we are going to move on to have a look at designing subnet C, which only needs 47 hosts. So what IP addresses do we have now? So remember we had 2 subnets. We've used the first one to represent, to be allocated to subnet D, with the biggest one, network. So now we're going to take the second one, second subnet, and use that to cater for subnet D. So to represent 47 hosts, how many bits do we need? So for that, these are the host bits that we can play with. So we only need 6 bits. Yeah. So with 6 bits, it'll give us 64. But remember, 2 of those IP addresses are not usable. So yeah, we end up with 62, which is more than enough to cater for our subnet C. Yeah. That leaves us with 1 bit to be used for subnetting, giving us 2/26 subnets. So that's the bit that's left over. Remember, left over, and we're going to use that to cater for our subnets. Yeah. So you started off with the /25, which used 7 bits to represent your hosts per se. And then now, since you don't really need all 7 bits to be used up for your hosts in subnet C, you only need 6. So you have 1 leftover bit that is going to be used for resubnetting. So you're now taking a /25 subnet and resubnetting that, making it a /26 subnet, like so. So with that 1 extra bit, you can have another 2 subnets, /26 subnets. Yeah? /26 subnets. We're going to take the first /26 subnet to cater for subnet C. Yeah, in binary, it looks like so. Now, subnet C network address is 172.20.0.128/26. Yeah, remember we started off with /25, and then now we have a /26 subnet. Yeah, binary notation of 128. Now we're going to determine the subnet mask for subnet C, a /26. So that'll make a subnet mask that looks like this. Remember, the subnet mask is where all the network bits are ones. Yeah, they used to represent the network. So that's the binary representation of your subnet mask. In decimal, you have a 255.255.255.192. So that's your subnet mask. Okay. Now that we've got our subnet mask, we're going to go ahead and have a look at the first host address, which is pretty much your network address plus 1, right? Subnet plus 1. So in binary, it'll look something like that. So that's your subnet, which is a 128 subnet. Now that's your first host IP address. Yeah, so you have 128 plus 1, making it a 129/26. Yeah? Okay. Now that we've gotten our subnet mask, we know our first IP address, hosted IP address. Now we're going to determine the last host IP address. So as you've seen before, we are using 6 bits to represent this subnet. So the last host address will be 2 to the power of 6 minus 2. Remember, 2 of those IP addresses are not usable. They're all 0 and they're all 1s. So that'll give us our last host address will look something like that in binary. Yeah. That's the subnet 128, and then convert those into decimal. You have a 162. So that gives us 172.20.0.190/26. Okay, /26. Now we're going to determine the broadcasting address. Okay, so the broadcasting address for subnet C will look something like this. Yeah, subnet plus the host bits that are all 1s. Yeah, so there's your subnet, your host bits 63, and that gives you a 172.20.0.191/26. That's your broadcasting address. Okay. So we've got subnet B sorted. Now, what IP address do we have now? So remember, we have 6 bits that we've used for subnetting to create your /26 subnets. Now we've taken the first /26 and we've allocated that to the previous network, subnet. Now we're left with this, the second /26 subnet. Yeah. So to represent 6 hosts, you only need 3 bits, right? So that's given like so. So 3 bits will give you 8 minus 2 usable hosts. So this leaves us with 3 bits to be used for subnetting. So remember, we starting off now with a /26. We've determined that we only need 3 bits to represent the network, where you only need 6 hosts IP addresses. So you have 3 left over to be used for subnetting, a subnet, a /26 subnet, like so. So we're going to take those 3 extra bits, and this is what your subnets are going to look like. Yeah, all the way through to that. So your subnets will now, you started off with /26. Now you've taken 3 bits from the host bits of a /26, and then you've given them to be used for subnetting. Yeah. So now you end up with a /29. You started off with a 6 /26. You've given that subnet portion of things another 3 bits to be used for subnetting. Now we end up with a /29, like so. So your range of network addresses, subnet addresses, will range like so, /29. Okay. So we're going to take the first /29 subnet and allocate that to subnet B, like so. So in binary, it looks like that, your /29 subnet. In decimal, your first /29 subnet will be 172.20.0.192/29. Okay. We've got another /29, so we need to determine the subnet mask for that first /29 subnet. Yeah. So /29 subnet, your subnet mask will look something like that in binary. Yeah. Convert that to decimal, and you have a subnet mask of 255.255.255.248. So that's your subnet mask for the /29 subnet. We're going to, you've got your subnet mask, you've got your subnet address. We're going to determine the first host IP address. Yeah. Network subnet network address +1 will give you your first host address. It looks like so in binary, converted to decimal. Yeah, your subnet, and that's your first host IP address in decimal. 172.20.0.193/29. Yeah, your last host address will look something like this. Yeah. And that's your subnet, your the 192 subnet, and that converted to binary 192 plus 6, that gives you 172.20.0.198. That's the last usable host IP address for this /29 subnet. Okay. Broadcasting address. Yeah, all host bits. Subnet plus host bits, they're all ones. like so. So you have 192 plus 7 gives you 199. Yeah. Last usable IP address in this subnet is 172.20.0.199/29. So the last network, subnet A, only needs 2 IP addresses. 2 hosts are going to be on that network. Yeah. So what IP addresses do we have? Now, we are going to have a look at, we're going to take the second /29 subnet and we're going to allocate that to subnet A. Yeah. So to represent 2 hosts, 2 IP addresses, how many bits do we need? Yeah, we only need 2, right? Just only need those 2. Yeah. So we're going to have, so we currently have 3 host bits, right? The /29 subnet. We just determined we only need 2. So we have a bit left over to be used for subnetting. So it's pretty much resubnetting a subnet. Now you started off with a /29. You determined you only need 2 of those host bits to cater for the requirements of network A. And then you have a leftover bit that could be used for, that is going to be used for subnetting. So 2 bits will give you 4 minus 2 usable hosts, which is enough to cater for the requirements of network A. Yeah. So that leaves us with 1 bit to be used for subnetting, that /29, giving us 2/30 subnets. Okay, we started off, we determined we only need 3 of those host bits in the /29 subnet, so you're left with 1. So with 1 extra host bit added to subnet that /29, you now will end up with a /30. A /30 network subnet that will have 2 IP addresses or 2 hosts on them. So we're going to take that extra bit and we're going to use that for subnetting to be the representative of your /30 subnet. So with that, it'll give you 2/30 subnets. Yeah. Now we're going to take the first /30 and allocate that to subnet A. Okay. So subnet A in binary will look something like so. Yeah. /30. And in decimal, that's what subnet A looks like. So you have 172.20.0.200/30. Yeah. So network subnet A looks like so in decimal. And it'll have 2 IP addresses on that. So we got our subnet address. Now we're going to have a look at the subnet mask. Since it's a /30 subnet address, the subnet mask will look something like that. Yeah. So convert that to binary, to decimal. Your subnet mask for network A will be 255.255.255.252. Okay. your first host address. Yeah. So it's subnet +1. In binary, it looks like so. Yeah, that's your subnet, which is at .200. And then you have your 1. So first IP address is 172.20.0.201/30. And your last host address will be subnet plus 2 to the power of 2 minus 2. Yeah. Which looks like so in binary. Converted to decimal, that's your 200 plus 2. So your subnet mask is 172.20.0.202/30. Yeah. Sorry, that wasn't a subnet mask. That was the last usable IP address, sorry. Yeah, in that previous slide. The broadcasting address, on the other hand, yeah. So in binary, it looks like so. Yeah. So that's your subnet, and then you add 3 to that, and that makes it 172.20.0.203/30. That's your broadcasting address. So your IP addressing scheme with your subnet D with 125 hosts, you'll have a /25 subnet. Yeah. With the first IP address being 172.20.0.1/25, your last IP address in that network is 172.20.0.126. Your subnet C with 47 hosts will have a subnet address of 172.20.0.128/26, and your first and last IP addresses will be .129 and .190/26. Yeah. Subnet B with 6 IP addresses on that is a /29 with the first and last IP addresses like so, and then your subnet A with only 2 hosts on that is a /30 subnet, with the first being 172.20.0.201/30. Last usable IP address is 172.20.0.202/30. Okay.